Okay, let's start. You've made a good choice in coming today. I hope by the end of today's seminar you will avoid making some of the mistakes that I have made in some of the writing I've done. Before I started teaching the Writing Scientific Articles course, which I do now for PhD students at KTH, I published a few papers and realized after publication, after print, that some of the figures that were in my papers were not the best designed figures really to show the data that I had. And I discovered that after commenting on a student paper. So there's always a lot to learn in making good figures, and they're very central to what we do in writing about research. In fact, often it's the first thing we do when we are in the process of preparing our research for publication or for writing, is to get that figure. We've done our work in the lab, we have gathered our data, and then to really understand our data, we need to look at the data, we need to visualize it, and we work on that figure, and from there, we go on to write the rest of our paper around those results, right? The results are central. So, I should just say my name, Rebecca Hincks. I am the head of the language unit at KTH, and I've taught English at KTH for many years, over 20, long time. So visual elements are important. Why are they important? We have this old saying, a picture says more than 1,000 words, right? You've heard that before? But there's another part of that. Tables and figures don't always actually speak for themselves. It's our job as writers about our work to interpret them for the reader, right? It's a combination of text and pictures that create a good scientific writing. Today, there's 3 parts of the seminar. First, about what kind of visual element to choose for your writing to avoid making that mistake that I have made earlier in my life. The second part will be how to structure a data commentary. So what is the core of your results section? How do you write about your results? And thirdly, some language input about how to refer to figures in the text and how to reference tables and so forth. Does that sound all right? I'm happy to take questions as long as they're brief ones throughout the seminar. Okay? So just raise your hands if you want to say anything. All right, so here we have some different kinds of visual information, just to remind you of the whole repertoire of figures that are out there. Charts, the round graphs, bar graphs. Also flow charts, we use those a lot in engineering to show a process. Can be very illustrative for your reader to understand how parts of a process are connected to each other. We also have line graphs down in the bottom left-hand corner there. And line graphs, of course, are good for showing changes over time, primarily. There are also drawings and photographs. That's sort of the range of figures that are out there. The question is when to use what. And we'll come to a little, in just a minute I'll show you a very good document that gives you kind of a choice scheme. But let's look at this first here, thinking about what are tables good for, what are photographs good for, and so forth. Tables. Do we have a problem with our mic? No, with our light? Okay. Tables can show a lot of data, can show very exact data, allow people to get the figures exactly. And they can also be used to present text in a way that's easy for a reader to sort of understand how different textual ideas are related to each other. So throwing in a table can be very helpful to explain when you have complicated relationships between things. Photographs, and now we can also be glad in this day and age that we all are carrying around a camera with us all the time. And if you're doing work in a lab, you might think about as you do your work or in a company that you keep a photographic record of what you're doing, because those photographs could become interesting elements of your report in the final stages. Not to be sort of illustrations or decorations, but as to be part of communicating the whole idea of the paper. So not decorative, but for communication. So a photograph makes your work feel authentic and gives you a general idea of things. But I'd like to stress there, not as decoration. I mean, if you have a photograph of something, you need to have a reason for having that photograph. Then we have drawings to allow us to focus on particular details. And there are drawing programs available that some of you probably are quite comfortable with or more familiar with than I am, but you can download drawing programs so you can get nice drawings of details that you would like to have as part of your report or as part of a presentation. Flow charts, as I said, show processes. Pie charts are used when you have a whole, 100% of something, and you want to show how that is broken down into the component parts. That's what a pie chart is good for, show the parts of a whole. Line graphs, as I say, are very good for showing changes over time. So whenever you have different measurements of something taken over a period of time, a line graph tells us right away. When we see that line, we think, aha, there's movement here, there's movement over a time period. And then bar graphs, when you have different categories that are separate from each other and discrete, and they allow you to compare how much you have of quantities of one item in comparison to others. So you want to keep these different purposes distinct from each other and not mix them up. One kind of graph that's not on here is the scatter plot, which is a very useful way of showing data, and that's the mistake I made in this published paper, that I should have used a scatter plot when I used a bar graph instead. This document here, I've given you a link here, and the slides will be available on the ARC website after the talk. But this will give you a link to a very nice document that you can use to kind of help you make a choice and see the range of figures that are available that you might not have think of in firsthand. And I'll just first show it to you and then enlarge it. Look here in the middle, thinking, what would you like to show? What do you need to show in your data? And you have a choice here, comparison. Do you want to compare things in your data? Do you want to show the relationship between different variables in your data? Do you want to show the composition of something, how all the parts contribute to the whole? Or do you want to show the distribution of your data? So think first about what it is you want to do with your data, and then we can go and look a little more in detail here. Just moving down. Relationship, for example. Do you have two variables you want to show the relationship between them? Well, a scatter chart would work well. But you also have these great bubble charts that can be done now, where you can add a third variable in there too, by showing where the size of the dot will show how big the value is. So that's nice. On the other side of this here, we have distribution, where you can also be using scatter plots, but you might also be using what they call histograms for a few data points, or a line histogram with many data points, scatter charts, and then also maybe you need to use a 3D plot. But one of the things I want to tell you also just in general about using graphs is that you want to avoid these 3D kinds of graphs as much as possible unless you need to show three variables. Composition. Here we have the line graphs down here, I think, changing over time. No, we don't, yeah. We have the stacked column charts. Here you can get a lot of information in these kinds of charts, depending on whether you have few periods of time or many periods of time. Oops. Go down again. And then maybe something is static too. So here, this is a distinction here, changing over time or static. You have simple share of the whole there. I'll do like this. So, it's not doing that. All right, anyway. We'll go up and look at the top. Comparison, that's often what we're doing in our work, comparing different amounts. And here we can see we have you can have a bar graph with variable width of your columns as well, or you can use charts with a table with embedded charts. That's quite fancy. your basic column chart when you only have a few items you're comparing. These web diagrams are interesting too. We use them a lot in course evaluations. If you have 10 questions, you've asked somebody and you want all the, some of the questions are you have everybody answers 5, other questions everybody answers 3. You can make this kind of graph here to show where the problems are in your data, where the area goes in is where you have maybe an area you can improve. Then the line chart for non-cyclical data, so data that moves in one direction over time, as I said. And then columns for a few categories, and many categories in a line chart. This would be harder to understand, but it might be working if you had variable over time. So I advise you to download this and consider all the options that are available to you, and think in a organized fashion about what is the best figure for your data. Okay, any questions on that one before we go? Go back to my PowerPoint. Here we are. Good. Okay, so a few more words on tables first, and then I'll talk some more about figures. You need to think in your table about where you place the information. And we want our familiar information, or it's often our independent variables, go on the left of the table. And the new and interesting information often goes on the right. So what we have here are some bad examples. You don't want to follow these. If you saw a table that looked like that, you wouldn't understand it at all. That's not even a table, really. It's bad. How about this? We have our water temperature here, and then we have the percent hermaphrodites, whatever it was that they were testing. That also doesn't work either, right? We don't have our independent variable, the water temperature, on the right-hand side. We have it on the left. That's where we expect it. So we don't do that either. This also doesn't make sense. This is not an appropriate table. We might make something like this in our first draft and then realize, no, that's not what the reader expects. The reader wants the stuff to be on the independent variable, the temperature, on the left, and then the dependent variable on the right. So that one's not good either. But how about this one? It looks pretty good. It's the way you expect it. Water temperature and then our dependent variable. But there's one thing here that can be improved. Anybody have an idea? You should take a look at how tables really appear in scientific publications, because another sort of beginner mistake you make is to put the table in with all of the lines on it, with the vertical lines as well as the horizontal lines. And that's not what we professionally do. We just have the horizontal lines on our tables. So you prepare your tables and then you go in and you work around to make a nice layout without the horizontal lines. That's generally the way it's done. Or without the vertical lines, I mean. Okay, good. Here's another, this same sort of, here's another table. It's laid out in the right way, right? We have our time here on the left, and then we have our hormone A and our hormone B. Another thing I'd like you to notice about this table is that the caption is above the table. That's another convention we have in writing, that when we have a table, we write what it is above the table. When we have any other kind of graphic, a figure or a photograph, the caption goes below, right? So it's just for tables that we make that exception. Anybody have an idea whether this is actually a good way of presenting the data? There's a lot of information there. But if you actually start reading the data points, you might think, maybe this isn't really the best way to show this data. We have time here. What about this? It says a lot more, doesn't it? We see how these variables are related to each other. And this is, of course, why we use figures as often as we do rather than just tables, so we can demonstrate to the reader right away that there's a relationship between the two series there. They vary with each other. Okay? So test your results in different ways and see what kinds of results you get. See what kind of what you can show with the different data. Okay, another point I'd like to make is the way the figures look. And this information has come a little bit from a man named Edward Tufte, who wrote a very influential book called The Visual Display of Quantitative Information. It's probably here in the library. It's nothing you'd want to buy. It's quite an expensive book. But his main point is all about cutting back, making things pure and simple in your figures. And often we want to make them sort of fancy and use all the functions that are there in our machines. But for the reader, we want things to be as simple as possible. And Tufte talked about something called the data-ink ratio. So you want to have as little ink and as much data. So everything that's in your figure should be contributing to showing the data rather than showing anything else, like around the data. Okay? So maximize the data-ink ratio. And Tufte also talked about chart junk. Junk in a chart is anything like, fancy patterns or 3D, visualization. We don't need the 3D to show 3 variables. Anything that kind of flies around is vibrating. Or try to avoid that. And also think about, what does the reader need to know? What does the reader know, for example, what this abbreviation means? When we're working on our studies, we often have, we start calling something short, PVQ or whatever we call it. And it's very clear to us what that PVQ means, but it's not so clear to the reader all the time. So don't use a lot of sort of codes and abbreviations in your data. And also think about making things readable, so you don't have tiny little text or hard to read text. So reader friendliness there. Okay? Good. Another thing we need to do, just sort of ethically in presenting our research, is to not mislead the readers, to make them think that you've got results that are really more stronger, more interesting than they actually are. So you can't distort your data. This means, the first point there, the magnitude of variability if a point represents a mean value. We're often working with averages. It's averages that we're showing in our graphs. This was the average of all those studies and stuff. But there might be a lot of variability behind that average. If you have an average, your point is 6, but some of your values were only 1, and some of your values were 12, but you have your average there is 6. You need to show on your data point how big the variability was. That's just also just basic good research. So get your whatever program you're working with to use your figures to show those variability bars if you're showing mean values. Also, generally speaking, you should be using your the axes on your scale should begin at 0, so you don't just sort of cut off the whole bottom of the scale, because it's not. It makes your data look more interesting if you have starting at another point. This is added, the qualifier whenever possible, because it sometimes isn't possible. But ideally, you should have scales at 0, and then if you have several graphs that are related to the same idea in your work, you need to have the same scale on them, of course, so readers can compare the values between the graphs. Good. And now a word about figure captions, or quite a few words. Generally, a figure caption is just a brief title, right? And it's not really on the figure itself. You don't want to have it there twice, like if you made your picture in Excel and you have the title up there, then you don't have it again on the caption, right? You only have it once. It's generally a short little noun phrase or a noun that says what this figure is. But some other things you can do in a figure caption are to define your symbols or your lines or your patterns or something. You can define abbreviations to remind the reader what the abbreviations stand for. You might also include statistical information if you've done statistical tests in that figure caption, and maybe something more about the experiment and the results. And the reason you might want to include all this information, particularly in a thesis, is that many readers are not reading the text very carefully. They're flipping through it and looking at the figures. That's sort of a natural human reaction to pick up a text and go for the pictures, right? So when you make the figure caption as informative as possible, you've actually taken advantage of an opportunity to inform your reader as much as possible by having a lot of information in the figure caption. Of course, you need to have this information in the text as well, but you can you can think about those readers who are not going to read your text carefully. All right. So that brings me to the end of the first part, which is what I had to say about choosing figures and putting captures on figures. Does anybody want to ask a question so far about this material? No? Okay, good. So we'll go on to writing about the results. And here I'm focusing on what I'm going to call a data commentary. So here's my data, here's my comment on my data. And these are some of the things we do in a data commentary. Well, the main thing is to highlight what results are interesting. We're not going to talk about every little data point, of course, but we're going to draw the reader's attention to what's interesting. And you, again, have worked with your data for a long time. You've prepared your figure. You've played around right and left. And what's important about the data becomes very obvious to you, but it's not going to be obvious to the reader right away. Just looks at the data. It's fast there. So you need to take some time to highlight what is most interesting in the data. Another thing you might do in a data commentary is to use this data to support the argument of your thesis, because you must have some sort of point you want to make in your thesis, right? And that data there is to support your point. So in your data commentary, you can say, what data is supporting your point and making your argument. Particularly in a master's thesis, or in a thesis in general, you might have a section in your thesis called theory, right? Where you've written about the theory behind what I'm doing, and the reason you do that in a master's thesis often is to show your examiner that you have learned a lot about this topic. You really understand the topic in depth, right? So you have that theory session. You might then think, when you get your results, how do these results support that theory? Maybe they don't support it, but how do they relate anyway to the standard theory or the general practice? So use your results section to do that. A basic function would just be comparing different data sets, just general neutral evaluation. Assessing the reliability of the data in terms of the methodology that produced it. So by this, I mean, okay, you have a method that you have described in your method section, and then you have your data, and you might need to consider whether the data is really reliable. Did I really have the right method there to get this data? Might there be some weaknesses in these results? So a little comment on the reliability of the data would be interesting. That shows that you're very aware of what you're doing, that you know that there's potential problems. Another thing we can do in a results section or in a data commentary is to say what the data means. What are the implications that come from this data? And finally, we might want to make recommendations based on the data. I'm going to show you a nice little example in a minute where Worsen writers have done all of these things in their section there. So this is taken from a textbook that we use in the academic writing class for the PhD students. And the question that must have been behind the paper that they have written here is that we have developed a new hockey glove for goalies, a goalie hockey glove. And we hope that this goalie hockey glove will keep the goalie's hands cooler while he or she is tending the goal, and be happier and make more saves in the game. So they developed this hockey glove, and then they compared it. They tested the temperature with a goalie playing for a whole hour, maybe with a thermometer inside the glove, however they were doing it. And these are the results that they got. The figure is figure 7. And changes in mean hand temperature for PCM and NFM glove conditions during exercise. We have time down here. And then these are temperatures. And notice, of course, this is not, as I just said, start your axes at 0, and this one does not start at 0. But on the other hand, if you think about temperature and body temperature, and if the body temperature were 0, the person would not be alive. So in this case, it makes a little bit of sense that they are just dealing with this range. Okay, so now I'm going to read this to you and we'll take our time on this. Don't worry, I'm not going to flash it away. Figure 12, in fact, it should be figure 7. Figure 12 displays the absolute skin temperature of the hand during exercise for both PCM and NFM conditions. As can be seen, after an initial decrease, hand temperature increased in each condition. An overall increase in temperature is inevitable since goalkeeping gloves of any kind prevent heat loss and evaporation, leading to discomfort and a negative effect on performance. However, the increase in temperature was more pronounced for the PCM condition. The PCM gloves were designed to maintain a steady and comfortable hand temperature. However, as can be seen, the PCM gloves did not perform as intended. Hand temperatures for PCM were consistently higher during the 45-minute exercise period, reaching a maximum temperature of just under 36 degrees. When exercise stopped at 45 minutes, hand temperatures for the two conditions fell at approximately the same rate. Thus, the PCM performance was inferior to that of traditional NFM and would not necessarily lead to enhanced goalkeeper performance. Too bad they failed, basically. You know, they hoped that their PCM glove would be better than the other one, and it wasn't. It was worse. So, too bad. And they have to deal with this in their data commentary. They have to say, you know, this is what we found, and this is what it means. So I'm going to we'll look at this now piece by piece. The first sentence here, figure 12 displays the absolute skin temperature of the hand during exercise. That's what we can call the locator statement. And we often have these in our writings to say, we introduce the figure and we say what it shows, right? This figure 12 does this. It's a locator. I've written that here, locate the figure. And we have a choice of words we can use under this displays, right? What do we want to say? We want to say shows, displays, illustrates. There's a whole variety of words you can actually put in that slot there. And here's a little opportunity to vary your language as you write. In the second sentence, here we have, as can be seen. That as can be seen is a nice little connector between the reader, the writer, the text, and the figure. It's tying them all together. As can be seen. You're seeing it, I'm seeing it, we're all seeing it, and connection. So that's a nice little touch. After an initial decrease, so they're describing the figure. First the temperatures go down, we can look at this, right? After an initial decrease, and then they both went up, they both increased. Okay? After an initial decrease, hand temperature increased in each condition. So that's the main thing you can see from that figure. And that's what they're doing in that second sentence there, main sort of result. So I'm going to call that connector with a main highlight. So the connector was the as can be seen, and then the rest, hand temperature increased. What do we see in the third sentence? We have a little comment. We expected the temperature to go up, is what they're saying. An overall increase in temperature is inevitable. And why? Because goalkeeping gloves, you know, they make you sweat, basically. Discomfort and a negative effect in performance. Think of those poor hockey goalies there with all that hot, you know, they're trying to save the goals and their hands are hot. But then we have this, there's a comment there. Then we have this important word, however. However is drawing the reader's attention to that, but we have a problem here, right? A contrast. It's a good word to use to show that what is coming in the following sentence, or what after the however, is a contrast to what I've just written. And the problem here was that the increase in temperature was more pronounced for the PCM condition problem. And then they have if we take this one, the PCM gloves were designed, they're reminding about the purpose. The PCM gloves were designed to maintain a steady and comfortable hand temperature. That takes us back maybe even to the introduction of this paper, where the writer said, we've made these new gloves and we hope that they're going to make us happier goalies, but they didn't. However, as can be seen, the PCM gloves did not perform as intended. So that's really the main result, you know, going beyond just the line goes up, the temperature increased, the temperature decreased. This is the main result, that we didn't get the results we hoped for. And then a comment here, hand temperatures for PCM were consistently higher, blah, blah, blah. And they go into more detail here about how it reaches the highest temperature of 36 degrees. Okay? And then describe the line in a little more detail when exercise stopped at 45 minutes, hand temperatures fell and stuff. And then finally in our last sentence here, thus. Thus is also a good connecting word that tells the reader that I'm about to sum up everything I've just written. Thus, boom, here comes the main conclusion. So PCM formis was inferior, a nice word there too, and would not necessarily lead to enhanced goalkeeper performance. It's all very nicely written there. Carefully chosen words, nice vocabulary, very clear, and well structured. So one thing I want you to remember from this is how you can structure a data commentary. You first start by locating the figure. Figure 7 shows this. And then you highlight the main information. You might want to comment on that. You might want to draw implications and so forth. And then maybe take another highlight or another result and maybe conclude at the end. And you have space in between to make all kinds of comments referring back to why you did the study or what it means or what the data really, really means. Question? Yes?
I'm wondering the papers are often the results section and then the discussion section.
Yes.
But here it seems to be close together.
Okay, good question. So the question is a really important question about how papers often have, well, they sometimes have separate results and discussion. So results section and then discussion section. And then they sometimes have actually results and discussion together. It depends a little bit on what field you're working in. But I think what you're asking is it okay to discuss my results at all if my section is just called results, right? And my answer is yes. It's okay to discuss them a little bit. You should, because it's unnatural for any person to just see some results and not start to think already in their head, like, what does this really mean? It's natural. So there's also been sort of a change over time in that whole question. So if you go back to writing maybe 50 years ago, there was like, these are the results, and then we'll talk about them later. But that's not done so much anymore. So we want to discuss them some. You could have a separate discussion section after a data commentary like that, where you discuss the results on an even broader level. And one thing that you might do in a pure discussion section that you wouldn't do in a pure results section is to compare the research, or the values with other research values, like have a lot of references to other people's work. You can have that in a discussion section that you wouldn't necessarily have in a results section. Yeah. Good, okay. So we want to say intelligent things about our data in our results sections. And here are a few expressions that you can use in English. Things like, this trend is probably due to, or one possible explanation is, or these figures contradict Brown's 2007 theory. You could also compare your results to someone else's results, like roughly similar to, these results are roughly similar to. So yeah, just a little battery of words that can be useful. And as I say, you want to appear as an intelligent person commenting on your data there. Here's some expressions of comparison. You can start with a connector such as whereas. Whereas X increased between the first and third hour, the rate of Y steeply decreased. What's also nice about this sentence is that we have increased in the beginning of the sentence, and then we have decreased at the end of the sentence. And so we have that those words that are in connection with each other, increase and decrease. Sometimes it's tricky to make comparisons. Just where do you put your verbs? It appears that model A gives a more accurate picture than does model B, instead of than model B does. What's different here? In speech, we would say model A gives a more accurate picture than model B does. That sounds right, in English? But if we say than does model B in writing, we've actually used a bit of a more formal register. That's nice to use too, than does Model B. It's a small thing, but it's a nice thing there. Okay, so just also in general about the whole results section, we have our introductions to the paper. And in the introduction, hopefully we're asking a question that becomes very clear to the reader. What is the purpose of this report? What is the question that I'm going to be answering in my results section and in my discussion paper? So in the introduction, we might be including what are the aims of the report and the questions you'll answer to. After well, it depends on how you write your report. Okay, I probably wouldn't start with the introduction. I would probably start with my method section because that's what I do first. And then I probably would do the results because then now as soon as I have my results, I'd start getting my figures and so forth. And then after that, I would be writing my introduction. I wouldn't be starting with the introduction and then writing the other part at the end. But if you have already written your introduction, you at least have your question ready. You have to make sure that after you write your results section, you're actually answering those questions that you asked at the beginning of the paper. And if not, it's easier to rewrite your introduction than to change your results. So you may have a draft of your introduction that you've already started with, but rework that introduction to make sure it asks the right questions that you answer later on. You don't have to stick to the same questions just because you got different answers than you thought you would. Okay, so the introduction is the one you can change the most easily. Then how about finding unexpected findings? What are you going to do? Things you hoped you wouldn't find. Should you ignore them? Sweep them under the carpet? What do you think? Yeah, maybe not. You want to talk about them. You want to show that you're aware that they're unexpected and discuss them in an intelligent way. Unexpected findings. So, for example, you can say something like, surprisingly, the data in category A did not conform to our hypothesis. One possible reason is that, and then if you can give a good reason, you again show that you're a very well-informed person who's on top of things. Okay, so definitely. Yes, that's true. Some great science has been done from the unexpected findings, right? Wonderful. Was it penicillin and things from bread mold? So exactly, they say they can be more interesting than anything else. Okay, so that was the second part. We're doing well here because I'm here in my third part. We have 10 minutes left, so there's lots of time. There will be time for questions. And this is just more about the basics about referring to visual information in the text. And of course, we number our visual elements. And they're not in the same series, though. We have a series of numbers for tables, and then we have a series of numbers for everything else, because that's a figure. So if you have 3 tables, 2 pie charts, 1 photograph, and 1 line graph, then they'll be numbered table 1, table 2, and table 3. And then we'd have 4 figures there, figures 1 through 4. Okay, so 2 different series there. And you use those numbers in the text, of course. So here's some of the locator statements. Remember I told you that first statement we call it a locator, where the figure 5. So figure 5 provides an overview. There's some nice language there for you of the collected data. Or the results are summarized in table 3. So those referring to visual evidence. In here, we have another set of locators that not only say, here's where you find their information, but they also summarize what's most interesting about that information. So the ones in this second group, the 5 sentences there, are providing content at the same time as they are locating the content. So as illustrated in table 7, the scores for X were very high. That has a highlight included in it, right? The results in table 2 show that all experiments achieved higher blah, blah, blah. The scores were high in all experiments. This is this kind here, see figure 2 in parentheses at the end. That's a very concise way of both locating the information and saying what is most interesting about it. But note in these that I don't have just comma, see figure 2. Okay, a lot of people want to write that way, and that's incorrect grammar. It has to be in parentheses, like this, see figure 2, or you need to have a semicolon here to connect those two ideas, to make it correct English. In Swedish, if any of you are Swedish speakers, I'm sure some of you are, you can have comma, see figure, see a figure, see a bild 2 or something. But you can't do that in English. Okay, it's not okay sentence. So parentheses or semicolon there. And then you also have parentheses in that last version there. In the last example here down at the bottom, if we look closely at the photograph provided, figure 2, we see that the left edge, in this example, we're including the reader in our writing. So by using we here, so we looking closely at the photograph and we see and so forth, that's reader inclusive. So that can be a nice way of writing too. Here's a slide about proofreading. These are some of the mistakes we see a lot that people tend to make, that they, for example, may want to use the definite article with the table, as seen in the table 7. We don't do that. We don't use the article with the tables and figures. So you don't have the. And you also want to write it properly so you have a space between the figure and the 1 way of doing it. And finally, a last slide about referencing visuals, because it's very tempting to take visual information from the internet. And of course, it needs to be referenced as well. And here I think it's nice to remind people that you can adapt things that you find on the internet. There's so many ways of making your own nice figures that are maybe inspired by something you've seen, but you've made it your own by working with it in some other kind of program. And in that case, then you would want to use a kind of reference like this, where you say this flowchart was reproduced from, or this was adapted from. So you still show where the inspiration came from, but you've made it your own and you've improved it and made it more appropriate for your purposes by working on a little for your text. And as you saw, I did that with a couple of textbooks on scientific writing for the material I showed today. Okay, so reference and adapt. And if you're borrowing anything from a foreign source that has different language in it, then you need to provide a translation and redesign the figure. Redesign the figure and say adapted from the source. Did you have a question, Suat, there? Yeah, okay, good. All right, so that brings me to the last slide to sum things up. Be smart about what kind of figure you use to show your results, was one of my main points. I also didn't talk a lot about this, but I want you to consider that figures are not there, or particularly photographs or something, they're not there as decoration, right? They need to be contributing to the message of the text, and they need to be integrated into the text in some way, talked about, described in the text, not for decoration. You're not there to just present your data and say, here are my results, but you need to comment on your data and discuss your data to make sense for the reader. You need to make sure that your results answer your question. You might have a structure where you have general comments first and details later. We didn't talk a lot about that today, but that's something you can do in a results section. You number your tables and figures. You make sure they're readable and they make sense, and you need to reference them. And those were my main points. So I'll show you one more slide to remind you that we have a Center for Academic Writing where you can get help. You need to book a little bit ahead of time nowadays to get a time there, but then you can have a chance to sit down with an individual teacher, one of us from the English section or the Swedish section at the language unit. And we'll read a few pages of your writing, see if you have any particular problems that you need to work on, and then have a meeting with you to discuss through the problems and help you with the kinds of questions you have. Jamie is very busy with that at present. And I do a little bit of it too. So are there any questions and things that you were hoping to get answered then, that you think I might be able to help you with, but I didn't include it already? You're all very satisfied. There, yeah.
Sometimes I have an appendix in the report.
Mm-hmm.
If I have more figures there, should I have a new naming system for the figure, for example, figure appendix 1?
Okay, so the question is how you number and refer to figures that appear in your appendix, and I can't exactly, I haven't come across that, so I hesitate to say one way or the other. It sounds like your idea to say figure appendix 1B or so forth sounds like a good idea to me. I think it probably is a good idea to say that they're in the appendix. Good. Thanks.